Now the next topic is acceleration. That is, we will derive the relation of acceleration in S and SH frame, that is Galilean transformation equations for acceleration. We know that acceleration is the rate of change of velocity, and we have the equation for velocities, that is ux dash equal to ux minus v and uy dash equal to uy, uz dash is equal to uz. So these are the Galilean transformation equations for velocity. We will use only first equation, that is we are studying only x-axis or motion along x-axis. So we will take this equation as ux dash is equal to ux minus v, or in general this equation will be written as u dash is equal to u minus v, because we are only taking x component. We have to no need to write x-axis or x script in the equation. So this is equation. And what is acceleration? Acceleration is the rate of change of velocity, this one, okay, u dash. Now, so we will find the acceleration by taking derivative of this equation on both sides. So differentiating this equation with respect to time on both sides, okay, it will become du dash upon dt is equal to du upon dt minus dv upon dt. Okay, so it's very simple. We have to take the derivative of this velocity equation on both sides. So we will get this. What is this? It is acceleration dash component, that is acceleration in S dash frame, and this is nothing, it is a acceleration in S frame minus, it will become 0. Why it is 0? Because v is the velocity of frame, and the velocity of frame is constant. You know that velocity of frame is constant because the frame is inertial, and inertial frame is that which is moving with the constant velocity or uniform motion. Therefore, the derivative of constant term is always 0. But u and u dash, these are the velocities of particle. This velocity is not constant. Therefore, we will get a dash is equal to a dash equal to a. So it means the acceleration in S dash frame is same as acceleration in S frame. This is acceleration in S frame, and this is acceleration in S dash frame. So when the parameter is same, it is called Galilean invariance. Galilean invariance. It does not vary under Galilean transformation equations. So the equation for acceleration is a dash is equal to a, that is Galilean invariance. Next one is fifth one, force. So we will study the Galilean transformation equation for force. So we know that what is force? Force is nothing, it is F is equal to ma. That is the product of mass and acceleration. So we will apply the Galilean equation for acceleration. So since Galilean transformation equation for acceleration, which we approved recently, a dash is equal to a, this one. So multiplying this equation with mass, multiplying with m, this equation on both sides, we will get ma dash equal to ma. So what is ma dash? It is f dash, and this is f. So as you know, when acceleration is invariance, then corresponding force is also invariance. it is also invariance, means force will not change with respect to frames. So this is our fifth equation, the equation for force. Now, in the next article, we have to prove law of conservation of linear momentum is also Galilean invariance. Next, this one is law of conservation of linear momentum is Galilean invariance. So this is our next article and next topic. We will not prove law of conservation of momentum. We will prove its invariance. Means the conservation law already exists, but we have to prove its invariance. Means we will use that law in S frame as well as in S dash frame. Then we will prove that this one momentum, conservation of momentum is constant or remain same in both frames. So in S frame, law of conservation of momentum may be written as m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, where m1 m2 be the masses of two particles. So I am taking here two particle system. Mass is mass of first particle and mass of second particle. Similarly, u1, u2 be the initial velocities or velocities before collision. Velocities of first and second particle before collision, before interaction or before collision or before interaction velocities, these are. And v1 v2 be the velocity of first and second particle after interaction or after collision. So you know that this formula we have already studied in the lower classes. This formula, that is, it is law of conservation of linear momentum. That is, momentum, total momentum before interaction or before collision is always equal to total momentum after interaction or after collision. So this is our law of conservation of linear momentum in S frame. Now, in S dash frame, in S dash frame, so in S dash frame, we may write this conservation formula m1 u1 dash plus m2 u2 dash equal to m1 v1 dash plus m2 v2 dash. Because m1 m2 remain same, they will not affected by the frames as well as dash. Therefore m1 m2 remains m1 m2, but this u1 become u1 dash, u2 is u2 dash. So in dash frame, velocities are u1 dash u2 dash before interaction, and velocities are v1 dash and v2 dash after interaction. So these are again law of conservation of linear momentum is written in S frame as well as in S dash frame. Now our task is to prove its variance, means both formulae are same. We have to prove it. Now we can start from any one equation. Let me start from equation number second. This one from second. So this equation is in dash frame. So I will convert this dash equation into without dash by using Galilean transformation equation for velocities, because dash is appeared in velocities. So using Galilean transmission equation for velocity, you know that it is u dash is equal to u minus v. So this is general equation for velocity transformation. So we will apply this formula for u1 dash, okay, become u1 minus v, u2 dash, u2 minus v, 2 and v1 dash is v1 minus v and v2 dash is v2 minus v. So these are 4 values: u1 dash, u2 dash, v1 dash and v2 dash. So we will put these values in equation number 2, and on solving or by simplification we will get, I think, the same answer as in equation number 1. So putting these values here, that is putting the values of u1 dash, u2 dash, v1 dash and v2 dash in equation number 2. So these u1, u2, v1, v2 dash, these are the velocities of particles, and v is the velocity of frame. So there is a little difference between v and v1. V is the velocity of frame, but v1 and v1 dash, these are velocity of particles. Similarly, v is the velocity of frame, v2 and v2 dash, velocity of particles. So putting these values, we will get m1 into u1 dash, that is u1 minus v plus m2 into u2 minus v is equal to m1 into v1 minus v plus m2 into v2 minus v. Okay. I put the values of these dash variables in second equation, and we will solve it. It will be m1 u1 minus m1 v, okay, plus m2 u2 minus m2 v, okay, equal to m1 v1 minus m1 v and plus m2 v2 minus m2 v. So m1 v will cancel out. Similarly, m2 v and m2 v, both are same on both sides, therefore they will cancel out, and we will get final answer m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay. So this is nothing, it is our equation number 1. It means the equation number 2 is reduced to equation number 1 by using Galilean transformation equation for velocities. So from here it is clear that the law of conservation of linear momentum is invariance. It will not vary. It will give the same answer in S frame as well as in S dash frame. So law of conservation of linear momentum is Galilean, is invariance under Galilean transformation. So it is called Galilean transformation invariance. So similarly, we will solve the next article, invariance of law of conservation of kinetic energy. So we will do this article in our next lecture. Thank you very much.